Hello everyone. In today's class we discuss about TTL logic gates, which is used in a practical circuit, and in this class we just only talk about the TTL IC numbers for different logic gates like a NAND, NOR, NOT, various types of logic gates. This is, first of all, this is 7/4 series. This is transistor logic series. They have many versions of other technology like a CMOS 400 series, but in this lecture we talk about only 7/4 series TTL IC chips. First of all, this is 7400. The name is quad. Why quad? There are 4 NAND gates are available, 2 input, and each gate are 2 input NAND gate. These 1 and 2 are input, 3 output. And first of all, this 7 is ground and 14 pin is connected to plus VC. And this sign, this is the sign, the notation top of the IC. This is a symbol. This is a symbol, and using this symbol we can detect the IC pin numbers. Otherwise, any wrong connection will be damage this IC. So this VCC we connect plus 5 volt, and here we can, this pin is grounded, and there are 4 logic gates are available. That's why it is quad. That means 4 2 input NAND gates. Okay. Next one is 7486 quad 2 input XOR gate. The IC name is 7486. This is XOR gate. There are 4 input, and pin number 14 is used as plus VC, pin number 7 ground, and there are 4 XOR gates are available, where 3, 6, 8 and 11 are the output, and 1, 2, 4, 5, 9, 10 and 12, 13 are corresponding inputs. Okay. Next is 7404, where pin number 14 is plus VC connected and pin number 7 is ground, and there are, this is known as Hex Not Gate because there are 6 inverter or NOT gate are connected. 1 is input, 2 is output, 3 is input, 4 is output, and remaining so on. This is 7432. This is also quad 2 input OR gate. This is pin number 7 is grounded, and this is plus VC connected, and there are 4 OR gates are available. Okay. This is 7402 NOR gate, and the orientation is just the opposite of the other gates. This is pin number 7 is ground, this 14 number pin is plus VC, and 1 is output, 2, 3 is input, and depending on this hardware there are 4 NOR gates are available. So this is known as 7402 quad 2 input NOR gate. Okay. Now next is 74138. This is a 3:8 decoder IC. This is 3:8 decoder IC, where G2, this is G2A, G2B, these two are active low enable, and G1 is active high enable. Okay. These from Y0 to Y7, these all are basically active low. These from Y0 to Y7 all are active low. Okay, these are the 8 outputs, and this ABC is a control input. These 3 are the control input. This 3 is a control input ABC, where we input our binary data, and the corresponding min term are getting low with the respective pattern of the binary numbers. And pin number 8 is connected to ground, and plus VC is connected to plus 5 volt. And when G2 equals to 0, one thing should be remembered, that when G2 equals to 0, G2B equals to 0 and G1 equals to 1, then the IC will be enabled, otherwise not. Okay. Then this IC is properly function, and the IC name is 74138 3:8 decoder. Next is 74151. It is known as 8:1 multiplexer. 8:1 multiplexer, and pin number 16 is plus VC, pin number 8 is ground. This is the notch symbol of the IC, and below this notch symbol, this is the starting pin, that is pin 1, and up to connect it to the other 18 dual line package. This is known as 18 line dual inline package, 8 dual inline package, because in the east side there are 8 pins. That means total 16 pins are available. These these S0, S1 and S2, where S2 is a MSB, that means we represent in this form. These are the control pins. Okay, these 3 are the control pins. These 3 are the control pins, and there are 8 outputs, which is represent from this or getting from this pin the 4 output, and remaining 4 output are getting from here. Okay, and sorry, these are the data inputs. I'm sorry, then this is not output, extremely sorry. These are the corresponding data input, because multiplexer symbol is like that. This is S2, S1, S0, and there are 8 inputs from E0 to E7, and Y, and another output is Y bar, and another input is known as enable bar. This is enable. If this pin is active low, then 74151 is activated. Otherwise, if enable is logic high, then this IC is deactivated. And one output is Y, active high output, and another output is active low output. There are 2 output are available from this IC chip. Okay, so next one is 74153. This is known as 4:1 multiplexer. Okay, 4:1 multiplexer. Here 2 4:1 multiplexer are available. 2 4:1. This is the upper side, this is the lower side, and here A, B, this is B1 input. That means the multiplexer block is, this is A, this is B, and there are 4 input, 1, 2, 3, 4, and 1 output Y. So this is the first output, this is the first output, this is the second output of the multiplexer, because there are 2 4:1 are available in this ICs. Okay, this is select 1, this is select A, this is select A pin or control pin, this is select B pin, and this strobe means this strobe pin is enabled for this IC. Just a minute, change the color. Okay, so this 2G pin, if these enable pin are used to activate this 4:1, because here one is 4:1 and another 4:1 is this. For activate of this 4:1, we select this pin. If these, the students please noted thoroughly that these pin are active low, so when strobe pin is getting low, then proper multiplexer will be selected, otherwise not. Okay, so one output, this is the output of first multiplexer, these are second output, these are the 4 data inputs, these are the 4 data inputs, these are the 4 data inputs. This is select, this is the common select for both ICs, first and second IC, because when AB equal to 0, then output, then data input 0 is selected, and 01, then 1, then 02, then 03, and so on. And this is for strobe for the same multiplexer. Okay, so this is 74153. 2 4:1 multiplexers are available. Now this is 74158. This 74158 is known as Octal Encoder or 8:3 encoder. Here the outputs are coming from this A2, A1 and A0. Okay, so basically these 3 output of encoder, because the encoder, from the encoder block diagram we know that in the encoder this is a priority encoder. Okay, first of all, this is a priority encoder. This is the 3 output, these are the active low output, because this is the active low symbol here. This is A2, A1, A0, and 8 active low input available is denoted by the symbol from I0. Just a minute, input is denoted by here, basically okay, this is the input symbols. Okay, this is the inputs, these are the inputs 0, 1, 2, 3, 4, 5, 6, 7. Okay, so this is I0, I1, I2, so this is I0, this is I0, this is I1, I2, and so on. Okay, GS and enable output are used for the cascading facilities, and this E1 is the enable pin. If this pin goes high, then the IC is deactivated, and if this E1 pin gets low, then only the IC will be activated. Okay, VC and ground are connected, plus VC and ground respectively. Okay, so this is 74148 Octal priority encoder. So this is one application of encoder decoder circuit. In the left hand side, first of all, look in the left hand side. This is 74148. This is Octal priority encoder IC. Okay, first of all, this is 74138. This is a 3:8 decoder IC. So this is first encoding the digit and then decoding, and there 8 LEDs are connected. So corresponding input output information are passed here, so the corresponding LEDs are glown. Okay, so first of all, look here, this is enable pin grounded, GS and enable 0 are cascading facility, that's why is open circuited, and here we connect 3 LEDs for status. So if we 0 pin equals to gets low, then according to priority encoder the output is get 1 on 1, that means 3 LEDs are glown. And if here 1 1 1, because these are the 3 output active low output. Okay, so just reverse of this output. So here we apply 1 on 1. So here enable 2 enables are grounded, this enable are logic high, this is plus VC, this is ground pin. So when 1 1 1, then this Y7 LED 8 will be glown. Okay, these LEDs are connected via this pin, but here these LEDs are like this connection, otherwise is not glow, and this is not a ground, this is plus VC connected. Okay, this LED are just the reverse operation, that means a common anode operation, not common cathode operation. Okay, these LED are just in the reverse operation mode. So if this pin is get low, then the corresponding LED will be turned on. So considering for 4, if this 4 input gets low, so according to the priority encoder the output is 100. So what is the status of this data? Output is 4100, but the output is represent 011 because this is active low. So 011 means these 2 LED are glown. Okay, so here 011 means this 3 output, 01 2 3, this LED will be glown. So depending on the various status, okay, the various status are available, and from the input pins there are lots of 8:3 encoder, there are 8 inputs are available. So depending on the various input, we just get the corresponding LED on and off. So this is basically encoding the binary logic and then decoding the binary logic. So this is the basically encoding, and this is the output function table of this encoder. Here look that if enable pin equals to 1, then the IC is deactivated, no other pin is, all are don't care, and output is remaining high. When it is 0, then if all are equal to 1, then according to the priority, what is the selection is 1, then output is 1 on 1. Okay, clear? Then this is active high, just consider active high, and when this 0 and all other don't care, and when this is 1, okay, this is 1, then another all other term equals to 0, that means 0 don't care, 0 don't care, 0 don't care. So that means this is disabled, and pin number 6 is enabled, because if we apply both gate 0 here, then according to the priority pin number 7 is selected. So depending on the higher priority of 6, we disable this pin. So we apply 1, should be apply here 1 here, otherwise the pin is activated. So if we apply here 0, then all other remaining bit don't care, because if this pin is equal to 0, but the priority is high, the pin number 6 is priority is very high. So that's why what is the status of 6? 6 means 110, but output is revert, that's why it is 001. Look here for the 7. When 7 equal to 0, I just back in the previous. Okay, look here that when this pin equal to 0, then output equal to 1 on 1. No, why? Because output is inverted. Okay, when all pin equal to 1, then output equal to 1 1. This is the one status, and remaining bit, the corresponding bits equal to 0, then the output is equal to corresponding high and low depending on the logic. And this is the normal decoder output, where three enable pins are available. When these enable 100, then the IC is deactivated, and for 000 the output Y0 equal to low. We already know that from 001 the output is Y1 and so on up to Y7. But when see that when this enable input equal to 1 and both equal to 1, otherwise both and 1, otherwise 1 equal to 1, then the IC is not activated or enabled. Okay, so here should be noted that the LED should be in the reverse connection, otherwise it is not properly work. Okay, so here all LED are short circuited and connected to the here plus VC. I again repeat, this is the plus VC point. Okay, Okay, now this is 7474. This is dual D flip-flop. This pin is D input. This is clear input. This is one clock input. This is preset input. This is one Q bar, and this is the first Q and Q bar. This is ground pin. This is the second D flip-flop. This is a D input. This is clear input. This is also the clock input, and this is preset input. This is Q and Q bar. Okay, this 7473 is a dual D flip-flop. Now next one is 74112 dual master slave negative edge trigger ticket flip-flop. Okay, basically this is the negative edge ticket. Here this is clock input. This is first checker flip-flop, K input, J input. This is preset, and this is clear. Plus 16 connected to plus VC. Plus 8 number pin is connected to ground pin. This is Q and Q bar of the first flip-flop. This is Q bar of the second flip-flop. This is Q of the second flip-flop. This is preset input of the second flip-flop. This is J and K, all clock, and clear input of the second checker flip-flop. Okay, so there are two checker flip-flops are available in one ICs. The IC name is 74112. Okay, next is 7483. This is known as 4-bit carry loop adder. In this IC, this is the plus VC pin. This is the ground pin. So here not 14 pin number 14 is plus VC, and pin number 8 is ground. Here some dissimilarities. This is pin number 5 is plus VC and 12 is ground. And carry output, this is carry input. This is summation 4. This is summation 3. This is summation 2. This is summation 1. And two numbers A and B. Each of number is divided into 4 bit A1, A2, A3, A4. This is A1. This is A2. This is A3, and this is A4. And number B, for the number B, this is B4. This is B3. This is B2, and this is where is B1? B1 is, okay, got it. This is B1. Okay, student must be noted that this is C4 is carry input and C output equal to carry output. Okay, now, okay, I will talk it later, earlier. So now in this lecture we see that there are lots of ICs are available in the 74 series, like 3:8 decoder. Just summary, this is 3:8 decoder. Then we see that 74151 is a 8:1 multiplexer. Then 74153 4:1 multiplexer. Then 74148 is a 8:3 or Octal priority encoder. Then here some logic of encoding to decoding conversion of binary logic. And here please note that all LED connected should be in the common anode connection and connected to the plus VC. Okay, this is 7474 dual D flip-flop. This is 74112 dual master slave checker flip-flop. This is 7483 4-bit carry loop adder. This is 7400 quad NAND gate, 2 input NAND gate. This is 7486 quad 2 input XOR gate. And these are the 7404 NOT gate. This is 7432 OR gate, 2 input OR gate, and this is 7402 NOT gate. Okay. Okay, now next is 7410 triple 3 input. This is 3 input NOT gate, NAND gate. This is 1, 2, 3 and the 13 are the input, and 12 is output. And here 4, 3, 4, 5 is the input, and 6 is output. 7 pin is a grounded. 14 number pin number 14 is plus VC, and 19, 11 is input, and 8 is output. This is a 3 input NAND gate IC which is available in the market. The IC name is 7410, and this is noted that this is the IC name 7420. Okay, student, please noted that here number is not mentioned, but I tell you that this is 7420. This is 4 input and NAND gate. There are 2 NAND gates are available in one IC package. This is 7 inline package. There is 7 14 pin. 14 pins connected to plus VC, and pin number 7 is connected to ground. And 1, 2, 4, 5. This 3 is no connection. 1, 2, 4, 5 is input, and 6 is output. And here 13, 12, 10, 9 is input, but 11 is a no connection. 8 number pin is output. So this is 7410 is a 3 input NAND gate, and this is 7420 4 input NAND gate. Okay, now next 7430, it is known as 8 input NAND gate. Here 11, 12, 1, 2, 3, 4, 5, 6, 7, 8 input and 1 output. This is 1 8 input NAND gate. Pin number 13 is a no connection, pin number 7 is grounded, and pin number 14 is plus VC. 743 is a very special. This is 8 input NAND gate. This is used for various purposes. Okay, for many mod counters or different for long counting, very for any register select or to address decoding in a 8085 microprocessor. This 7430 IC is very much uses, and this is 1 2 3 4 5 6 7 8 inputs and 1 outputs are available for pin number 8, and 9 10 13 are no connection. Okay, next one is 7411. This is 3 input AND gate. This is 3, and each 3 input are AND gate. 1 2 13 input, 12 output. This is 7411. Pin number 7 ground plus VC is connected to pin number 14. This is 9 10 11 input and 3 4 input, 5 input and 6 output and 8 output. This is 3 input. Why 3? Because first 3 represent 3 AND gate, and next 3 is each of the AND gate is represent or connected by 3 input combinations. Okay, so this is 3 input NAND gate 7411. This is also very important for the detailed electronics applications. Okay, this IC is known as TL074. Okay, I just write here. This is the operation amplifier, quad operation amplifier, because here 4 operation amplifiers are available, and the advantage of this IC is this is not requirement any. This is known as TL074. Okay, TL074. This is minus VCR connected to minus 12 volt or minus 15 volt. This is plus VC plus 12 volt. These are connected the biasing voltage, and here 4 op amps are connection. This is inverting, non-inverting and output. This is inverting, non-inverting output, and so on. So there are 7 in line, 14 pins are available. Okay, this TL074 advantage is the bandwidth. Gain bandwidth product is very high, frequency response is very good, temperature not drifting, characteristics not drifting with temperature. Then also noise level is very reduces, and there is a no off-signal requirement in this operation amplifier. Okay, so that's why TL074 is very advantage to use any electronics project or commercial purposes.